It's time to go around and around and around with the rock cycle on PS100. Since the rock cycle is a cycle, it doesn't really matter where we get on, and since I'm currently surrounded by igneous rock, we might as well start there. Igneous rock, like this granite found at Notch Peak, is just liquid magma that's had time to cool off. Sometimes it cools far below ground, and other times it makes its way all the way to the surface before it cools, either as a volcanic eruption or a lava flow. Ever since this granite was exposed to the surface, physical and chemical forces have been wearing it down, breaking it into smaller and smaller pieces. If you look closely, you can see that the granite in these mountains was made from magma that contained different minerals. The pink is potassium feldspar, and white is a combination of calcium and sodium. The gray and transparent bits are quartz, and the black is iron. Ultimately, the elements will break these minerals apart, turning the white bits into clay, the gray and clear parts into sand, and the black into rusty iron oxides. Because these different products will be different sizes, some will get blown or washed downhill more easily, while others are more likely to stay put. That's why you find smaller, lighter weight stuff in the valley below and larger chunks up above. Once it reaches the valley floor, sand weathered from the granite can be buried, compacted, and cemented to form sedimentary rock like shale or sandstone. Anytime you see layers or strata like this, you know that you're looking at some sedimentary rock. These layers of sandstone have been exposed at the surface by tectonic uplift and erosion, so now the same forces that formed it are quickly breaking it back down into sand. And that sand will likely go on to form other sedimentary rock in the future. But way down underneath this sandstone, about 10 kilometers below the surface, there's enough heat and pressure to turn sedimentary rocks into the geological mutant called metamorphic rock. Within the crust, there's generally not enough heat to completely melt rocks into liquid magma, but there is enough to make it soft enough to squish and bend, and for the minerals and rocks to reform into something new. That's what happened with this slate in the appropriately named Slate Canyon of South Provo. This rock was heated under high pressure deep underground, where the clay minerals of the original shale hardened and new minerals began to grow. This created a new fabric in the rock called foliation, which can be seen in this outcrop. After millions of years beneath the surface, it was pushed back up by a collision between continents. If those forces had pushed it down instead of up, it might have melted completely into magma. That magma could have flowed back up and cooled to form an igneous rock, which would then become either a metamorphic rock all over again, or it could have ended up at the surface, eroded, deposited, and buried once more. So the cycle goes around and back and forth. That's it for this episode, but you'll find more science and research opportunities for BYU undergrads in the description below.